Welcome, ladies and gentlemen. This is our 56th lecture, and this should concentrate on hypothesis testing for correlation. So, we are going to discuss this, the hypothesis testing, as hypothesis testing is the crucial aspect of the inferential statistics that you must be knowing. And we already, from the whole lecture, we have arrived here that the hypothesis testing is the main aspect or the chief aspect of the inferential statistics. So today we are discussing the hypothesis testing for the correlation. The hypothesis testing for correlation coefficient determines if a relationship observed in a sample is statistically significant and likely exists in the population. The process involves stating a null hypothesis that there is no correlation in the population and an alternative hypothesis that there does exist a correlation. A t-statistic is calculated using the sample correlation coefficient and sample size, and this value is compared to a critical value from a t-distribution with n-2 degrees of freedom to determine whether to reject the null hypothesis. So degree of freedom here is n-2, the correlation coefficient is r, and the sample size is n. So what are the steps involved in the steps for hypothesis testing? In all the hypothesis testing, in fact, we have to follow this protocol that first set up the null hypothesis, that the population correlation coefficient is equal to 0. That is, there is no linearship or no relationship, no linear relationship between the two. And as we have already discussed, that in the correlation coefficient, the data is neither nominal nor ordinal. The data in correlation coefficient is either from the ratio scale or from the interval scale. So we should remember that, and we state the hypothesis then that the population correlation is coefficient is equal to 0, that is no linear relationship. And then we have the alternative hypothesis that the population correlation coefficient is not equal to 0. So this can be a two-tailed test, one-tailed test, and for positive correlation, of course, or one-tailed test for a negative correlation. We proceed ahead. Then we choose the significance level. Normally, we choose alpha is equal to 0.05, that is 5%, to determine the threshold for a statistical significance. Then we calculate the test statistic, use the sample correlation coefficient and the sample size to calculate the t-statistic with the following formula. T is equal to r root n-2 divided by under root 1 minus r square. This was the third step to calculate the test statistics T. Then we have to determine the degree of freedom. This is n-2. So depending upon the n, we will have the degree of freedom. And n is the number of the sample number number of the entries, or one can say number of the items, or whatever it is. Find the critical value. The next step is to find the critical value from T statistic given in the table at alpha is equal to 0.05 and degree of freedom n minus 2, and compare this with the calculated T value that we have arrived earlier. Then we have to take a decision, make a decision. That is, reject the null hypothesis if the calculated T statistics falls in the rejection region. That is, it is less than the negative critical value or greater than the positive critical value. So, hypothesis is rejected, and we do not reject the null hypothesis if the calculated T statistic falls between the critical values. So we have to rather, if the null hypothesis is accepted, then we have to reject the alternative hypothesis, and we have rejected the null hypothesis, then we have to accept the alternate hypothesis. So we move ahead. Then it is interpretation of the results. If we reject null hypothesis, we can conclude that there is a statistically significant linear correlation between the two variables. Whereas if we do not reject null hypothesis and accept the alternative, it means that we do not have sufficient evidence to conclude that a linear correlation relationship does exist between these two variables that we are studying. So this is the protocol for the testing of the hypothesis. We have done it, and in fact similarly we will set up for all the hypothesis testing. So we have done it. We will now discuss some of the examples without the help of the SPSS, and we will discuss these examples, some of these examples with the SPSS also. So we proceed ahead. We have an example where we have to find whether a linear correlation relationship exists between the television and the exam scores. Time put in looking at the TV and the exam scores. So the null hypothesis is that the population correlation coefficient is 0. That is, there is no relationship between hours of TV watched and the examination scores. Then the alternative hypothesis, that is the population correlation coefficient is not 0. There does exist a linear relationship between hours of TV watched and the exam score. Then we proceed ahead. We collect the data. We have taken the data of 32 students. So here n is equal to 32. And the correlation coefficient for the sample is calculated to be r is equal to minus 0.45. Based on this, we shall be calculating the T statistic. We calculate the test statistics. Use the formula for the T statistics which was given earlier. We have n is equal to 32. So degrees of freedom is n minus 2 is equal to 30. Now we calculate that the t value is minus 2.760. Now we go to the table to find the critical value. For a two-tailed test with alpha is equal to 0.05 and degree of freedom is equal to 30, the critical values are approximately plus minus 2.042. Now we compare the two values. We find that since the t statistics t is equal to minus 2.760 is less than the negative critical value, that is minus 0.2042. So this falls in the rejection region. So the null hypothesis has to be rejected. We conclude that the null hypothesis is to be rejected, and then we arrive at the interpretation that there is statistically significant evidence at the 0.05 level to suggest a linear relationship between hours of TV watched and exam scores. So the negative correlation indicates that as TV watching increases, exam scores tend to decrease. So this was to test the hypothesis on correlation between the hours spent on television and the examination score, which we have found to be negatively correlated. Then we shall give another example for testing the significance of correlation. So here, suppose a study measures the hours studied per week and exam scores for a sample of 10 students. The data yields a sample correlation coefficient of 0.0707. We want to test if this correlation is significantly at the significance level of 0.005. So we have been given this task. R is given, significance level is given, N is provided, and in fact they have provided the results also themselves. Just we have to check it and test the hypothesis. So null hypothesis we set up as there is no relationship between hours studied and exam scores in the population. So if there is no relationship between that is our null hypothesis, that as much there is no relation between the study hours and the exam scores. So the alternative hypothesis that there is a linear relationship between the hours studied per hour and the exam scores. We proceed ahead. Then calculate the t statistic from the n and the r that we have been given, and this comes to be t is equal to 2.828. So the calculated t statistics is approximately 2.828. They have done it for us. Then determine the critical value for p value. We go to the book. The degree of freedom is here n minus 2, that is 10 minus 2 is equal to 8. N is y, n is 10, and there are two variables, so n minus 2, 10 minus 2 is equal to 8. Okay, so we have the degree of freedom and we have the alpha 0.05. So we have to check for the critical value where in our book. So what we find that the critical value of a two-tailed test with degree of freedom at 8 and alpha is equal to 5 is 2.306. Now we compare it with the calculated value. Since our calculated t value is greater than the positive critical value, so what happens? The null hypothesis falls in the rejection region. So the null hypothesis is to be rejected, and so the alternative hypothesis is to accepted. So what is the finding? The finding is that the null hypothesis, that there does not exist any correlation between the hours studied and the exam score is rejected, and the hours of study hours of study and the exam scores are positively related. And since they are positively related, so what does it mean? That as much study hours are provided for the study, as much increment in the examination score. So that way we have arrived at a conclusion. Okay, we proceed ahead. Then we proceed ahead, and the conclusion from the previous experiment was that there is sufficient evidence to conclude that a statistically significant linear relationship exists between the number of hours studied and the exam scores. Then one more example. This example is about the positive correlation between the numbers of hours spent in a test for studying for a test and the percentage scored in it. It is also a similar example where the R has been given and the level of significance have been given 5%, that is alpha is equal to 0.5, R is equal to 0.668 here. Then what we do? We write the hypothesis. The student is testing for the evidence of positive correlation. So this is a one-tailed test. Okay. So the null hypothesis, that there is no relation between these two variables, whereas the alternative hypothesis, that the as much time is being given in the studies, as much chances of success or the percentage. So we move ahead, and this is the values we have been given, the critical values. The n is 40, alpha is 0.05, and the critical value here. So the critical value we have been given as 0.559, and the t value that we have been given is 0.668 here. So what we find, that the calculated value is greater than the critical value, and so this is why we come to the evidence, or we come to the conclusion, that at the 5% level of significance there is sufficient evidence to reject the null hypothesis in favor of the alternative hypothesis, and the student's claim is justified. There is evidence, so the null, we accept the alternative hypothesis, that as much studies put in, as much it would be better. So we reject the null hypothesis, and the student claim is justified. There is evidence to suggest positive correlation between the number of hours spent revising and percentage scored in the test. So this is done here. Now we will shift to the SPSS format. For this we do this. We have here this. We have brought the file here. This we click here. We open, and we have this data for the correlation. See, there are students who in fact want to find if there is a relation between the salary that they would receive with the marks, with the communication skill, with the general awareness, or with the IQ score. So the students, they have to find it, because those students who are in the final year, they are very much concerned about their placement, and they want to improve their weaker aspects, the t values, and then we compare. So we have this, and we will see how we do it. So we go to analyze, and we go to the correlate, and then go to the bivariate. Okay, then we will shift all the variables to this box. We have shifted the not student, we don't have to shift. We have to shift the salary to this box. We have to shift the marks to this box. We have to shift the communication to this box. We have to shift the general awareness to this box. We have to shift this IQ to this box. Then we have this here. So we go to the options. In options, we have this here, means and standard deviation and all. Okay, we continue. We have already here the Pearson's kicked. So we do the OK. Now this is a box which has come as a result. What we find here, that these for salary, this is the Pearson correlation, this is the significant, and this is the n. For this is the for marks, Pearson correlation, significance, and n. For communication score, this is the Pearson correlation and the significance and the n. For the general awareness, this is the Pearson's correlation, this is the significance, and this is the n. For the IQ score, this is the Pearson correlation, this is the significance, and this is the n. So we have got this box as a result. We look at the first, the Pearson correlation, salary. What we find that along with the marks, their R is 0.702, and it is less than 0.001. This gives the significance alpha, the SPSS level of SPS, you can say SPS calculated value, and for with the correlation of the Pearson correlation with the communication is 0.8, and the t value is also less than 0.01. The relation of the Pearson correlation between salary and the general awareness is 0.461, and this is 0.2, and the general and the correlation and the IQ is 0.864, and this is greater than, less than again 0.001. So we take one by one examples. So what we have to do, we have to check these values, these stage values, whether they are to make whether these changes are significant or not, these values are significant or not. We have to compare this value with 0.05. So coming to the correlation between the salary and the marks, we find that the SPSS value is 0.01. 0.01 means that it is less than 0.05, which we have alpha. So what we do, we reject the null hypothesis. we reject the null hypothesis that there is no correlation between the salary and marks. We reject this, and we arrived at the conclusion that there is relation between salary and the marks. Then we come to the communication skill. It is here again the t value is smaller than 0.05. So again the null hypothesis is rejected, and as the null hypothesis is rejected, so again we say that there does exist a relation between salary and the communication skill. Then we come here. This is general awareness. So this value is 0.020. This is, and this is 0.461. So it is 0.02. It is again smaller than 0.05. So in this case also the SPSS value is greater than the alpha. So sorry, SPSS value, yes, SPSS value is greater in this case. It is 0.05, but SPSS value is only 0.02. So it is again smaller. So again null hypothesis is rejected. And if it is rejected, what does it mean? There does exist a relation between salary and the general awareness also. And with the IQ score also, we find the same, that the null hypothesis is to be rejected as it is less than 0.05, and so there exists a positive relation with the IQ score also. So what we do arrive at the conclusion that salary is of course related to all these factors positively, and the students have to in fact prepare for all these aspects of their personality. They have to improve the marks, they have to improve the skill communication, general awareness, and IQ score also. So with this, we again go back to the analysis. We again go to analyze, and then we come to the correlate, and then this time we will see the partial correlation. In partial correlation, what happens? We have to control one or other factors to find the relationship between the two variables. So we select salary, the variable, and the marks here, bring marks here, and control all the other factors. Okay, this factor also control, this factor also control, this factor also control. Then we click here, see what is here. We have got these three variables as control variables, whereas there is it gives a relation between salary and marks only, and we find that salary and marks are very highly correlated, and also we get the t-test, which is 0.066, meaning that this SPSS value is greater than alpha, meaning that we accept the we accept this 0.05, 0.06. So we accept the null hypothesis that there exists a relation between the two. So this way we can study about each of these factors and compare their values, t values, with the alpha values, and then find our conclusion in the partial correlation. The bivariate correlation, it was another aspect. Here we control other variables to find the relation between the two. So ladies and gentlemen, I hope I have been able to give you something about these tests in hypothesis testing in the correlation. So with this, I take leave from you. Thank you very much.